Hey everybody, welcome back to the second last session of season 10 of Code Vipassana. This season has been a milestone season for us, and we thank everybody who has been a part of this season with us. We can't wait for you to see what's next, and we're so proud of what we've done and what the developer community has achieved. So today we'll build a powerful stateful E2E AI agent app in Java with ADK, AlloyDB and Gemini. So what is the objective? Well, the objective is pretty simple. It is to allow anybody to search for patents based on a textual description and get a detailed explanation of a specific patent from the search results. And Gemini and the entire application can be deployed serverlessly on Cloud Run. So what will you learn in this lab? Well, you'll learn how to create a AlloyDB instance and load a public dataset. You'll learn how to implement advanced vector search in AlloyDB using the ScaNN Recall Eval features. You'll learn how to create an agent in ADK using Java. You'll learn how to implement database server-side logic in Java serverless cloud functions, and you'll learn how to deploy and test the agent in Cloud Run. So this is the architecture diagram, a high-level one for us to follow, and that's pretty much it about the explanation of the code lab. So the first thing that we need to ensure is that we have a Google Cloud project set up and we have billing set up. How can we do that? Well, let's go open the console.cloud.google.com page. Go to the project picker, which is just on the right of the Google Cloud logo. Click on new project if you want to create a new project or just use an existing project. Let's say I'll just create a new project S10-L6. I will go ahead and hit create. Once the project is created, I will select the project. Once the project is selected, I will note the project ID. Please note that for me, my name and project ID are the same, but for you, it might not be that case. So make sure you look at what is your project ID and save it. The next thing that we'll do is we'll go to billing and enable billing. So you can see if I go to credits, currently I have only $1.46 in credits from last time, which is not enough to do a lab like this. So what we'll do is just paste any one of the Code Vipassana credit links that you get in your email, redeem the credits. So I will just redeem them right now. Click on accept and continue, and the credits will be successfully applied. So now if I go to manage billing account, you can see that there are no projects linked to this billing account right now. So what we can do is go to billing, go to projects, go to the lab that we go to the project which is created, which is S10-L6, change billing. Let's just refresh it. And select the account that we just created. So because the names are identical, we don't know which one exactly it is. So let's try the one on the top, set account. Let's go back to the page where we checked how many credits do we have inside billing and see if it's updated. So this is still $46 in our lab. That means we need to select the other credit link. So we will go here, change billing, and select the one on the bottom. So just remember now, whenever you redeem a new credit link, it will always go to the bottom of the list. Now that you can see it's applied, I will just go to credits once again. And you can see the billing account has been changed, the trial credits account has been changed. and now I have $5 worth of Google Cloud credits. So you need this before you proceed for today's lab, because we will be using some database features which are charged by the hour. So yes. The next thing that we need to do is we need to set up our Cloud Shell terminal and enable some APIs. So how we can do this is, again, let's open a console.cloud.google.com page. Just click on this icon that says activate Cloud Shell. Open the Cloud Shell in a new tab. Authorize it from here, but just close this window. Authorize it here, and the Cloud Shell will start opening. And once it opens, you can see something like this. So the next thing that we need to do is we need to set our project ID inside the Cloud Shell terminal. The command to set the project ID is gcloud-config set project, and your project ID, for me my project ID is s10-l6. For you it will be your unique project ID. So make sure you remember your project ID. Once you set it, it will say updated property core/project and update your project ID in yellow. The next thing that we can do is enable these APIs. We can just copy this command or also use this link. Let's just use this link. Make sure you're in the same project that you just enabled in your Cloud Shell. Click on next. It says you're about to enable the following APIs. Once you click on enable, give it some time. It will start enabling all the APIs. The process will start, and once we are done, we can proceed. Once this button is grayed out, that means that you have successfully enabled all the APIs, and we can proceed to the next step, which is step 3, which is the database setup. Now for setting up the database, we can go to the search bar, type in AlloyDB, and click on the first option, and you'll be greeted with a screen like this. So let's go ahead and click on create cluster, and then we need to configure some details to create our AlloyDB cluster. All the details that you need are provided in the code lab. So let's take the cluster ID as vector-cluster. The password we can take as AlloyDB. Database version, you can choose the most latest one. Region, let's choose US Central 1 because we always use US Central 1 for all our services. Networking, we choose default. So for networking, it's changed, it's a bit down here. So we choose default. It will ask you to set up connection, so just set up connection. Select use an automated IP range. Click on create connection. Give it a minute or two and it will create the connection. Once it's done, you will see that the network is set to default and you'll see a tick mark here. The next thing that we need to do, we've already done setting up the connection. We've clicked on create connection. The next thing that we need to do is set up our instance. So let's go ahead and configure this. So we will go here. We will go to setting up our instance. The instance ID that we're supposed to put is vector-instance. Let's copy that, paste it. Single zone is enough for this code lab. We don't need multi-zone, but if you want to leave it, that's fine too, because the credits will anyway get over. And then once this is done, you can just go to the next step and click on create cluster. Once you click on create cluster, it'll take about 5 to 10 minutes for the creation of the cluster and the creation of the instance. So just wait for a bit, let it happen. Even if it shows ready here, it's not completely ready right now, because if you scroll down, the instance is still being created. So just wait for this to finish, show successfully created, and then we can proceed with the further steps. You can see that my instance has been created, so we can go ahead and proceed with the code lab. So the next step that we need to do is we need to ingest the data, which is basically we will be using the public dataset and just inserting some data into this so we can use it for our further embeddings, vector search, etc. So let's follow the steps. Let's go to AlloyDB Studio. Click on Postgres as the database, Postgres as the user, and we'd set our password to be AlloyDB. Let's do that, click on authenticate, and we can just go to the editor. Once we're in the editor, we need to enable some extensions, create some tables, etc, etc. So let's copy this command, go to the editor and run it. You can see statement executed successfully. If you want to check if the extensions were enabled or not, just copy the second command, run it, and it will show you that the extensions were enabled. So the next thing that we need to do is we need to create a table. How we'll do this is we'll create a table called patents_data with all of these columns, all of these data types and lengths. Let's go ahead and click on run. You can see statement executed successfully, and we have a patents_data with about 12 columns. The next thing that we need to do is we need to grant the permission to execute on the embedding function. So let's go ahead and do that. We're done with that too. The next thing that we need to do is grant the Vertex AI user role to the AlloyDB service account. So you can do this two ways. You can do this manually by going to the IAM page, or you can also do it from the Cloud Shell terminal. Let's do it from the Cloud Shell terminal. So let's get the project ID and set it as a variable inside the Cloud Shell terminal. You can see it says active configuration and the project ID has been set. And then we can just copy this command, go to the Cloud Shell, just press enter, and it will do its magic and give the role to the AlloyDB service account. You can see if you see something like this with 1 at the end, you're good to go. All the permissions have been granted. The next thing that we need to do is we need to open this file called insert_scripts.sql and load some data. This data has come from the open source Google Patents dataset. So that is what we'll be using right now. If I just open this file, you can see this is a very big file. So what we can do is let's just download it, open it inside using any editor that you have. I will use Visual Studio Code to open it, and you can see it looks something like this. So this entire thing from insert into till the end is one query. So let's just copy, there are about 50 queries here. Let's just copy 10 right now. So I will go ahead and copy 10 queries since this is a lot of data. So we do not want to waste our time. So that's it. I will copy 10 queries, copy it, go ahead inside our editor and paste it and click on run. You can see statement executed successfully. Once that's done, we can proceed with the next step. So the next thing that we can do is we can create the embeddings for the patents data. But if you see the data that we've put right now, we've already created the embeddings for all the data that we have. So this data, a virtual power manager for when plural virtual machines are running, this entire column has already been converted into embeddings, and this is the embedding for it. So if you've just copied this from the GitHub and you have just pasted it, you do not need to worry about this step, but all you would need to do is just copy this command, go ahead to another tab, and we're just showing you how to run it. So if we click on run, you can see that embedding, this is the newest text embedding model, textual embedding model, and then it creates an embedding which looks something like this. And we already have that inside our data. So that's great. So let's just run this command to set the field as an embeddings field. So AlloyDB knows. Let's click on run. Let it run, let it do its magic. And you can see statement executed successfully. The next thing that we can do is we can try and perform vector search. So we can go ahead and try running this query. So what we'll do is we'll just paste this query, and try to run it, it is ordering by the embeddings and it is searching for sentiment analysis. So you can see that it's analyzed all the 10 queries that it had, and it's given us, a title for the matches that it has gotten. So the vector search works. That's great. The user search text is sentiment analysis. We are converting this embedding into an embedding using the same model that we have done the embeddings with, and this method shows that we have used the cosine similarity method. So what we're going to do next is we're going to take AlloyDB and use it for vector search RAG, and AlloyDB takes this to the next level. Why it does that? Well, it uses something called inline filtering and recall evaluator. It's specified in the code lab what this is, so you can just go ahead and run it. So even though we have provided 100 rows in the SQL file, because of the trial credits that have been provided for this lab, it will be a little difficult enabling scan index and then searching it with inline filtering, etc. Like it says in the code lab, if we have less than 100 rows, we will not be able to use the scan index in the first place. So let's just skip those steps. So let's just skip the steps and see how we can take the database logic to the web serverlessly. So what we can do is we can now deploy the database that we just created on Cloud Run. So what we'll do is we'll open this new link that says console.cloud.google.com/functions/add, and we will select Cloud Run. We will select use an inline editor, and all the configurations that we need to use are present in the code lab. So let's go ahead and do that. Let's take the function name as patent-search. Let's do that. The region, let's take it as US Central 1. The endpoint URL we can take as Java 17, but let's just confirm it with the code lab. Yes, we choose Java 17 as the runtime, and we allow for unauthenticated invocations. So let's go ahead and do that. The next thing that we do is we just click on create. Let it create the function. Until then, you can just edit the runtime and edit the source. So the next thing that we need to do is we need to replace the placeholder code in hello http function and pom.xml with our functions. So if you go back to the code lab, you will see that we have the data. It says hello world.java, and this is the file that we need to execute. So we will just copy this code and paste it there, and we'll be able to use it. So that's great. Let's just copy this code. It is also hyperlinked in the code lab. So if I click on this patent-search.java, you can see that it is right here. So I will go ahead, copy this file, go here, hello http function.java. I will click on edit and paste it here, and you can see that it will give us an error that the runtime entry point and the code does not match. This is because we just changed it. So what we'll do, we'll take the patent search and paste it here. That should work, and the error should be resolved. The next thing that we need to do, we just need to take the pom.xml file, open it from the GitHub, copy this too, close both the GitHubs, and just go to the pom.xml file and paste it too. Let's check if we need to edit anything. Well, we need to change the class name in the file, and we need to change the placeholder in the AlloyDB connection credentials inside the Java file. So these are the AlloyDB credentials. So let's just go back to this file and search where we need to update the credentials. You can see it's Postgres, then project, and here is where you need to put in your project ID. So for me, my project ID is S10-L6. For you, it will be your specific project ID. The next thing that we can do is just rename this file. So let's rename it to patent-search.java, and we're good to go. We can click on save and redeploy, and then we can go ahead and proceed with the other steps that are required. So the next thing that we need to do is we need to edit this revision and go ahead and set up our VPC connector for outbound traffic. So let's go ahead and do that. Click on edit and redeploy. Go to the networking tab, connect to a VPC network, use a serverless VPC network, add a new network, add a new connector. It will ask you to enable the serverless VPC access API. Just enable it, give it 1 or 2 minutes to get enabled. It will be enabled, and then the next thing that we need to do is set up this connector. So what we'll do is we'll just provide a name for the VPC connector, and we'll leave the network value on default and a custom IP range of something like 10.8.0 that is available. So let's say patent -search. The important thing is it should be in the same region as as all your other instances. You can use a custom IP range, let's say something like 10.8.0. In scaling settings, minimum instances 2 is fine, but let's see what the code lab says. It says the maximum instances have to be 3 and the instance type has to be F1 micro. So let's go ahead and make that change. Maximum instances is 3 and the instance type is F1 micro. Once that's done, we click on create. It will go ahead and proceed with the creation of the VPC network. This will take some time, so don't worry, just give it some time and then we will get started. Once it is created, you will see that we have a check mark, the service is created. So we'll just go ahead and select it. Then all we need to do is select it, opt all the traffic to this network and click on next. So all traffic through the VPC and click on deploy. After that is done, after the cloud function is deployed, we can just go ahead and test the same function that we did the sentiment analysis using our Cloud Run endpoint. So this is currently created, it is deployed. So once you're done setting the VPC connector, what you can do is you can go ahead and test it out using your Cloud Run endpoint. So we will take this, go back to the Cloud Shell terminal, set up project ID. After that, we will use this curl command, paste it, and then paste our endpoint right here. So it will look like something like this. This is the endpoint that we have, which you will get from here. This is your deployed endpoint. Then you can just go ahead, paste this. It will hit your database and give you the result that we exactly got in our CLI. That is very cool. So we can proceed with the next step. Now let's go ahead and build the ADK agent today inside Java ADK. So let's go to the Cloud Shell terminal. We already have it open, and now open the editor. So we will go ahead, open the editor, close the terminal, and we will just open a terminal here also. The next thing that we need to do is we need to create a folder in the root directory, and let's call it ADK agents. Inside ADK agents, we will create our entire structure, which looks like this. So let's go ahead and do that. Let me just check if I already have an ADK agents. I do not. So we can go ahead and create it. So let's say ADK-agents, press enter. It says please enter a path that exists. So what we'll do is from the terminal, we will do mkdir ADK-agents. Now it will have created a folder in the root directory called ADK-agents, and then we can select this, press on OK, and it will reinitialize everything in the terminal to be open inside the ADK-agents folder. Now what we can do is we can set our project ID inside our terminal. So gcloud config set project, and my project is s10-l6. So that is what I will be setting it to, and now we're ready to use. So let's go ahead and create this structure. We're already inside ADK agents, so let's go ahead and make the pom.xml file. So we need a pom.xml file. We need an src folder. Inside that we need a main folder. So we need an src folder. Inside that we need a main folder. The next thing that we need is inside a Java folder and then an agents folder. So we need a Java folder, an agents folder, and finally we need the app.java inside of it. Great. So we have the two files that we need to edit. After that, we will open this GitHub repository and copy the code for app.java and pom.xml. So let's go ahead and do that. This is the code for the pom.xml. Let's just copy that. Go to our editor, paste it inside pom.xml, and then go to app.java. Go to the src directory. Here is the app.java. Copy this, paste this inside app.java. We will need to replace some things. Do not worry about it. So let's go ahead and do that as well. First, we need to add the dependencies for the Google Cloud and Google ADK dev. So let's just make sure that we have these dependencies inside our pom.xml. So let's just see if we have ADK and ADK web. Let's search for it. Do we have ADK? We have the ADK core and we have the ADK dev web UI. So we're good to go. The next thing that we need to do is we need to ensure that we have Java 17 plus and Maven compiler are correctly configured in the pom.xml. Well, since we have the pom.xml from our project, we are completely good with that code. Finally, what we can do is we just need to go ahead and edit some things inside our final app.java. This is a simplified version of the code that we've just put inside of our editor. So if you open app.java, you can see we have a prompt, we have a vector search endpoint. This is where we're supposed to put our endpoint. So just go back to the place where you deployed your endpoint, take it, paste it here. Other than that, we have a lot of different things. We have defined a tool, which is what we'll use, which will take the search text and find matching schema according to it. It will also use invocation context. You can read about all of these things inside the code lab. How do we use invocation context for stateful applications? And then finally, let's go ahead and run this. So to run this, what we need is we need a Gemini key that we can get from the AI Studio. So let's go to the AI Studio. You can just go to aistudio.google.com. Click on Get API Key, Create API Key, and create it inside the project that you have used right now. So let's create this API key, copy it, and let's see in the code lab where are we supposed to paste it. So inside CDK, inside the ADK-agents folder, we're supposed to export it inside the Google Cloud terminal that we're using, and we're supposed to set vertex AI as false since we want to use the Google API key. Let's go ahead and do that. So export, let's copy this first. So Google underscore API underscore key. So Google underscore API underscore key equals to our API key. Let's go ahead with that. The next thing that we need is Google Gemini use vertex AI as false. That's great. Now finally we can just compile the first agent using the Maven command, and we should see an interactive response from the agent. So let's just go ahead and do that. You can see Maven has already started compiling everything. It started installing the dependencies. Give it some time. It will do its magic. You can see that we have Java ready. So we should not have any issues. You can see the agent has been deployed. So it says you, and we can just enter any kind of command that we want to enter. So if we say hello, the agent says, hello, how can I help you with your patent search today? That's great. So the next thing that we can do is we can actually go ahead and deploy our ADK function to Cloud Run. So Cloud Run is similar to deploying any other application. So what we usually do is we create a Docker file, then we push the Docker image, and then after that we deploy it to Cloud Run. Although we can just deploy it to Cloud Run using one single command inside of our function. So what we can do is we can just go ahead and exit this, clear it, and we can use this command to deploy this to Cloud Run. So inside Google API key, we just need to paste our Google API key. After that, just press enter. It will start doing its magic. So it's asking us for the service name. Let's say we put ADK-patent-search. Let's press enter. It's asked us to select a region. So let's select US Central 1 as always. So that is number 34. The next thing it asks us is, can we allow unauthenticated invocations? We say yes. And then it will start finally building the container, building the policy, setting the IAM policy, everything, and it will deploy this. By this time, let's just test it using the web UI. So we can also always test ADK agents with the web UI. So what we'll do is we'll use this command to test it over the web UI. So until this is building, we'll just open a new terminal on the side, configure our project ID. So gcloud config set project s10-l6 for me. And then we paste this command. Once we paste this command, it will go ahead, it will scan the project. And it will run it with Spring Boot on port 8080. So you can always go ahead after deploying it to Cloud Run and try testing it with web UI. If you've done the previous Python sessions, what you can do is you can go ahead, run this command, and then you can see that this is how it will look like. That's it. You should be able to do all of this up. If you want, you can deploy it to Cloud Run, but just know that you won't be able to run it for a long time due to the trial credits. And then finally use the cleanup function. So open this link, go to the Cloud Resource Manager, and if you'd like, just delete the project that you worked in right now to just make sure that your Google account is clean. So don't worry about any money or anything like that because we're on trial credits. You don't need to worry about that. But for today, so congratulations, you've just built your patent analysis agent by using the capabilities of ADK, Vertex AI, and vector search. And this is just not a very normal thing to do because we've actually progressed in making contextual similarity searches very transformative, efficient, and truly meaning driven. So you have all the links. Let's go ahead and finish up today's session. Thank you. You can always connect with us at Discord, comment down in the YouTube video, and leave a thumbs up. See you in the next video.